Hi everybody, this is Raj again. Today, this is the second video on substitution method. First was when you always substitute. That was if e power is different than linear, or trigonometric angle is different than linear. You always put. This is the second one where you have to substitute, but sometimes you have to change. Okay, suppose you have these questions. These questions are based on that you have a function of sine x, and here cosine x. Here power will be 1. Okay, here function of sine x, and here cosine power is 1. Okay, in this case you have function of tangent x, means there could be more than one tangent, and here will be only secant square x. Here cosine 1 power, here secant square x. Here function of log x, and here this. These both should be present in the same question in the form of pairs. And here sine inverse x, and here 1 minus x square root, both in the pair. Here will be only 1 minus x square in the denominator. Here x in the denominator. Here in case of tangent inverse x, 1 plus x square in the denominator. Okay, and here you have 2 sin x cos x. That should be this in the numerator, this in the numerator, this in the numerator, this in the denominator, this denominator, this denominator. And here this can be anywhere in the numerator or denominator, and you have function of this sine square and cosine square. And here this beside dx will be this number. This will be beside dx. This could be anywhere in the numerator, denominator. Here you have 1 power more than this, and here n plus 1, here n. Then sometimes we have to change, and here ex and ex. Here ex, that will be beside dx, and this could be anywhere in the numerator or in the denominator. And these are your 14 questions, and you can look these questions and write it down on a different page. Okay, let's start. Today I will give only hint, and rest you can do. Otherwise this video will be very long. Okay, the first question, if you see, the first question has a pair of sine and cosine, right? And sine x is beside dx, and power is 1. This is not power 1. I know this cosine and sine x, this power is 1 by 2, and this is 1. We will put this number, we will make this as a function of cosine x. We will put here cosine x, this equal to t, and derivative will be minus sine x dx, that equal to dt. And you will take sine x, negative sign other side. Here left over sine x dx equal to minus dt, and this will be equal to this power t is this one, t power 1 over 2 square root, you can write this way, minus dt. And this will be minus t 1 over 2 dt, right? You know the integral of 1 power increases by 1, and you will divide by 3 by 2. That will be your answer. Okay, I will leave up to here, because otherwise nobody want to watch that long video. Okay, then you have this second question, secant square x dx, and here 1 plus tangent x. Okay, again this is very straightforward. You have this secant square beside dx, and this is a function of tangent x. This is function of tangent x, and this is already given, and that is the same pair I mentioned above. I will put here, tangent x, 1 plus tangent x. that equal to t, and the derivative of this is secant square x dx that equal to dt, and this will be equal to integral, and this will change into dt, and this one will change into t, and you will get here dt over t, and this equal to, cause everything is in t now, this will be equal to log t, and after that, and absolute value don't forget, and c, and t value you have to replace, and that will be log, okay, 1 plus tangent x absolute value plus c at the end. Okay, now your third question, you have given x cube over x square plus 1, this is cube dx. In this question, if you see, this is x square, but this is x cube, and but I'm thinking about this one, xn plus 1 and xn, this combination. Okay, I can make that combination if I divide this x cube into x square into x dx over x square plus 1 dx. Okay, and I will put this one because it's a derivative there, and the rest is function of, if you notice here, this is x is 1 power and this is 2, is x square and x, these are both connected this way, right? And this you should have present, and this you should have beside dx. Yes, this is beside dx, and this is your function of x square. I'll put x square equal to t, put x square plus 1 that equal to t. Put, if there is a constant, put that as well, that will help you in the question. This, the derivative will be 2x dx that equal to dt, and this x dx that equal to 1 over 2 dt. Now replace with this will be your still you have to find here x square only, because you have x square only, that x square will be t minus 1. Here you have a t minus 1, and this x dx, this value, and x dx is this equal to 1/2 dt, right? And I will write 1/2 dt over this t cube, and this will be equal to 1 over 2 integral t minus 1 over t cube dt. I already mentioned that in a previous video. If you have one term in the denominator, then you will divide each term with this denominator term, t over t cube minus 1 over t cube and dt. Please, if you didn't watch that video, please watch that video. That will help you to. Okay, after that you have to solve this question. This is not done. And now fourth question you have. Okay, fourth question you have x power 8 and over 1 minus x cube 1 over 3 dx. And you can write this as x cube square, here x square over 1 minus x cube 1 over 3 dx. Okay, here I will use this one, xn plus 1 and xn. Okay, because this is cube, this whole thing is x cube function of this, and this x square is function of x power n. And after that we will put, when you put this whole thing, okay, if there is a constant beside a variable is added or subtracted, put the whole thing equal to a new variable. I'll put, that will help. Put 1 minus x cube that equal to t, and the derivative will be minus 3x square dx that equal to dt. And x square dx, you will get here x square dx that will be equal to minus 1 over 3 dt. And this equal to your integral x cube, and find x cube as well. X cube that will be equal to 1 minus t. Okay, from here, if you have to find x cube, take this side and t to that side. T when comes to this side, it will be 1 minus t, and this goes to other side, that will be x cube only, that side out here, 1 minus t. Okay, this will be 1 minus t square into this minus 1 over 3 dt over t 1 over 3, and this will be equal to 1 over 3, then 1 minus t this square and dt over t power 1 over 3. This 1 minus t into 1 minus t we always expand, as I said in my previous video. You always expand that one, and that will be, we change numerator's product into addition. And then I will do this 1 minus 2t plus t square and dt over t 1 over 3. And now you will distribute, because this is a sum and there is a presence of one term, or in other case is product of two terms. I will divide this with this, this with this, and this with this. Then you can, after that you can integrate, and this will be equal to I will do only this step, rest you can do yourself. 1 over t 1 over 3 minus 2 t power 1 take away this, okay, write this way here, this plus t square over t 1 over 3 and dt. And this will be equal to one more step I will do. This will be t minus 1 over 3 dt, and this is outside, don't forget to put a big bracket, 2 this 1 and take away 1 over 3, that will be 2 over 3. 1 take away 1 over 3, that will be equal to 2 over 3. This will be t power 2 over 3, 2 by 3, and plus t power 2 take away 1 by 3, 2 take away 1 by 3, that's 6 minus 1, 5 by 3. This will be 5 by 3. Then after that you can solve yourself, and here dt, and here integral, and the rest you can do yourself. Okay, this was your fourth question. Now fifth. Okay, the fifth question, you have sine 2x over a cosine square x plus b sine square x. I already mentioned above. Okay, because angles are not same, we will make first angle the same. This will be 2 sine x cosine x over a cosine square plus b sine square, and this is dx. Okay, this function derivative is there, this also derivative is there, right? We will put the whole thing, this whole thing equal to a new variable. We will put this a cosine square x plus b sine square x, that equal to t, and the derivative will be 2a cosine, and cosine the derivative which is minus, that will be minus sine plus b 2b sine x into cosine x, and here dx, that equal to dt. You know the derivative of sine square is 2 sine x. Here 2 sine x, cosine x is common, and you left over with minus a here. Okay, this is 2 common, cosine x sine is common, 2 common, sine x is common, right? You left with b and minus a from here. I will write here b minus a dx equal to dt. I need this number and this number and this number, and I will take this to other side, and it's constant. Everything should be in dt or a constant, and this will give you 2 sine x cosine x dx, that equal to 1 over b minus a dt. And this question fifth will be equal to, then integral will be equal to, this value is 1 over b minus a t, and here is t dt, and this equal to 1 over b minus a integral dt over t, and that you can do yourself. It's not done. Question is done, not done. You can do after that yourself. This sixth question is this 1 over 1 minus x square, this square root sine inverse x dx. If you notice, it is a pair of sine x, and this is in the denominator. This should be in the denominator, and this is a function of sine inverse x. And you will put sine inverse x, this equal to t, and its derivative is 1 minus x square and dx, that equal to dt. And you can replace this here, this number 1 over x square and dx is dt, and sine x is here, that will be 1 over t. This is 1 over t, and this is dt, and the rest you can write yourself. It's not done, and here you can do rest of the part, and replace always with a t value. Now seventh question, you have 9 x square minus 4x plus 2. Here you have 3 x cube minus 2x square plus 2x plus 3. Okay, if you notice here degree is less than this. If first check if this function's derivative is present is in the numerator. Okay, the derivative of this is 9x square, yes, that's there. Then minus 4x, yeah, that's there. Then plus 2, this is here, plus 0, right? It's already there. If this direct derivative is not there, then this cubic must have a factors. If the cubic has no factors and direct derivative is not there, you cannot solve a question. And suppose you have this question, I will just put here in a bracket. This question, suppose you have this over x cube plus x plus 1 dx. You cannot solve, no answer. Okay, you cannot solve this integral because this has no factors. Then they have to give, if this direct derivative is not present in case of a cube, then this must have a factor. If no factors, you cannot solve this one. I repeat again. Okay, now put this equal to 3x cube minus 2x square plus 2 plus 3, this equal to t, and derivative is 9x square minus 4x plus 2, and here dx, that equal to dt. And now replace, and this will be equal to dt over t, and then you can do